Hello, good day everyone. So let's talk about increasing and decreasing functions. And this is all about differential calculus. So let us have first the concept or overview about what is all about increasing and decreasing functions. A function describes how one quantity changes with respect to another. So to determine whether a function is increasing or decreasing, we need to study how its values or outputs or change as x values inputs increases. So let us take a look with this illustration. So if we're going to look at this one, this is a function. So in this part, we have here the different intervals. If we're going to look at the different intervals from a to b, so if this interval a to b, this function is increasing. So from this interval ab, the function increases from a to b. But at this point, it is horizontal. Okay, horizontal with this part, the x-axis. So therefore, this horizontal or where the function is equal to 0 is called the critical point. Or in this function, the function is said to be stationary at the critical point. So it does not move. So therefore, in this point B, that is parallel to this horizontal line here, this line, kini mga line nga gipamutang ani. So therefore, this one is what we call as stationary. So on this point is what we call as the critical point. And going here from B to C, so if we're going to look at here from this part, the function decreases. So from the interval B to C, the function decreases. But at the point here, line sad, you have the line again. So at the point here, this is what we call as the minimum point, which is the critical point. So, and then C to D, then this interval C to D, the point increases until this function up to E. So therefore, if we're going to recall about angle between two curves or angle between two lines, if we're going to observe, if we're going to make a tangent out of this one, okay, for example, if we're going to make a tangent out of this one, we're going to create an angle. Okay, an angle which is an acute angle. So take note that the first derivative of the functions or the equation is said to be the slope of an functions or an equation. So therefore, if the first derivative is greater than 0, it means that the function is acute and that is increasing. But if we're going to look at it, we're going to take another point of tangent here in this graph. Okay, it creates the theta here, or the angle between 2 points or the curves, is it creates an angle which is an obtuse angle. So therefore, the first derivative is lesser than or negative side here. So therefore, that is lesser than 0. So therefore, we could say that when the function is increasing, that is the first derivative is greater than 0, but when the function is decreasing, so therefore we could say that the function is lesser than 0, or the slope, the first derivative is lesser than 0. So take note of this one because this is an increasing and decreasing function. We will be using the first derivative test, or how we're going to determine whether this one is increasing or decreasing. So let us have definition. So when we say that the function is increasing, so a function f of x is said to be increasing in the interval if x sub 1 is lesser than x sub 2, or the function when x sub 1 is lesser than the function x sub 2. So this means that as x increases, the function also increases. So if we're going to graph that one, the curve moves upward up as we move from left to right. So if we're going to look at the figure, from left to right, it moves upward. So that is the graphical representation of how does it look like, or the increasing and decreasing functions. So we have here decreasing function. So what do we mean by decreasing function? It is defined as a function f of x said to be decreasing on the interval if this condition will be met here or shall be met. Okay, this one, x sub 1 is lesser than x sub 2, is the function x sub 1 when x sub 1 is greater than the function when x is when the value of x is equal to x sub 2. So this means that the x increases, the function decreases. So graphically, the curve moves downward as you move from left to right. If we're going to look at here from the interval b to c, so it moves downward from left to right. So the function decreases. So we have here, if that is a constant function, it means that the both function when x is equal to x sub 1 is equal to the function when x is equal to x sub 2. For all x sub 1, x sub 2 in the interval, then the function is a constant on that interval. The graph is horizontal line. So that is the graph is horizontal here. Okay, this one. This is a constant function. So we are going to look back again that the function, when the first derivative is greater than 0, the function increases or the graph increases. At that particular interval, it increases. But when the first derivative is lesser than 0, it means or implies that the function or the interval, in that particular interval, it decreases. So let us have the role of the derivative. The first derivative tells us the slope of the tangent line at each point. If we're going to look back or recall about the angle between two curves, so we are going to get the slope of the tangent line. So therefore, we are going to get the first derivative. And that first derivative is what we call as the slope. So in this condition, if the first derivative is greater than 0, the function is increasing. So the slope is positive, that is rising, based on, if we're going to graph that one. But if the function, the first derivative of the function is lesser than 0, the function is decreasing. So the slope is negative, meaning to say it is falling. If the function is, the first derivative is equal to 0, the function is constant or stationary. So flat tangent, the turning point. So therefore, this is the reckoning point, or this is the critical point. Okay. So steps to determine whether to determine increasing or decreasing intervals. So let us follow these steps in order for you to have the better understanding about how to determine whether the function in that particular intervals is increasing or decreasing. The first step is to find the first derivative. So what is the first derivative? You have to compute the first derivative f prime x. So that is the first derivative, or y prime. So the second one is find the critical point. So in the critical points, we're going to equate that. After taking the first derivative, we have to find the value for particular x and equate that one into 0 or solve for x. Next step is make an intervals. So make an interval rather. Make an interval. So we need to say divide the x-axis into intervals based on the critical points. So we have to divide. The fourth step is that test of sign of the first derivative. We have to choose test value in each interval and plug into the function, the first derivative of the function. When that is, the first derivative is greater than 0, let's recall that that is increasing. And when the first derivative is lesser than 0, that is decreasing. So that last step is that we have to write a conclusion. We have to indicate whether the function is increasing and where it is decreasing in that particular interval. So those are the following steps that we need to follow in determining whether in each interval, in this particular interval, whether that one is increasing or decreasing. Okay, let us try example number 1. Find the interval or intervals where the function f of x 2x cubed plus 3x squared minus 36 is increasing and where it is decreasing. So the first step that we're going to do is we need to find the first derivative. Okay, so this one, the first step, we have to write this one. The function f of x is equal to 2x cubed plus 3x squared minus 36x. So the first step that we're going to do is we need to find the first derivative. The first derivative is equal to, we have here 6x squared plus 6x minus 36. So after that one, we have to find the critical points. How to find the critical points? We have to equate or factor and solve that one into x. So we have here, we have to factor. Okay, this is factorable by 6. So there's x squared minus x minus 6. This one is plus x minus 6. So we have here equated by 0. So this one, the factor of this one is x plus 3 and x minus 2. Okay, because the sign for the second term is positive. So therefore, we have to use positive 3 and negative 2. And after that one, we have to equate. This is step number 2, which is we have to equate and solve for x. So x plus 3 is equal to 0, x is equal to negative 3, and x minus 2 is equal to 0, x is equal to 2. So these are the particular intervals that we're going to have. So next step, we have to, okay, draw that one in a line. So if this one is 0, and the particular intervals is this one, 1, 2, 3, negative 3, and this one is 2. So in this particular interval, okay, this is our critical points here. So these are the particular intervals that we could have in this equation. So the first interval, okay, this one, the first interval is negative, let's open, negative infinity and negative 3, close to 3. So this is interval number 1, and the next one is close to negative 3 and 2. And the next interval, this is interval number 2, this is close to 2 and positive interval. That's interval 3. So interval 3, 2 to positive infinity. Negative infinity minus negative 3, negative 3 and 2 plus positive infinity. I want that interval 1 and interval 2 and interval 3. So let us solve for the value for the interval. So whether this one is decreasing or increasing. So let us now test number 3, or that is step number 3. So we have now the 3 intervals based on the illustration. So let's now proceed with testing, choosing the value for x. In test number 4, in interval number 1, okay, this is interval infinity, negative infinity to negative 3. So we have to choose between negative infinity to 3. So negative 3. So therefore we can choose let us choose let x is equal to negative 4 because it is within the interval. So negative infinity to negative 3. So let us choose negative 4. So if we're going to substitute that one in the function, then negative 4 in the first derivative. So therefore we have here 6 times negative 4 squared plus 6 times negative 4 minus 36. Where did we have this function? So we substituted here in this function the first derivative. So 6x squared plus 6x minus 36. So we just simply substitute the value for negative 4. So negative 4 squared plus 6 times negative 4 minus 36. So the function is, the value of this is equal to 36. So if that is the first derivative, when you substitute negative 4 here, So what is the decision or the conclusion? So therefore, the first derivative is greater than 0. So therefore, this is increasing. At this particular interval, I1, negative infinity, open negative infinity to the close negative 3. So to close negative 3, that is the function is increasing at that particular interval. So next one is I to interval 2. In interval 2, this is close negative 3 and close to 2. So let us have from negative 3 to 2. So we could make use of 0. Okay. So f prime of 0 is equal to 6 times 0 squared plus 6 times 0 minus 36. So f prime 0 is equal to 30 negative 36. Okay, this is negative 36 because this is 0, 0. So we could have a conclusion that this one is f prime of x is lesser than 0. So therefore, this is decreasing. In this particular interval, the function is decreasing. And the last one is interval 3. In interval 3, is close to 2 to positive infinity. So let x is equal to. So 2 to positive infinity, so we could choose or we choose 3. F prime of 3 is equal to 6 times 3 squared plus 6 times 3 minus 36. So f prime 3 is equal to, the function is 36. So we could have a conclusion that the function is greater than 0. So therefore, this is increasing in this particular interval 2 to positive infinity. So now, if we're going to look at the graph, okay, this is the graph. In interval negative infinity to 3, so this one, negative infinity to 3, this one, so the graph is increasing. But in negative 3 to 2, negative 3 to 2, this one, the graph is decreasing. And in positive 2 to positive infinity, here, in this particular 2 to positive infinity, the graph is increasing. So, bisan pag wala tayo graph, we could now conclude that this particular interval, the function is increasing or decreasing. But looking at the graph, so we could now say that the answer is correct. Diba? This one is increasing, decreasing, or increasing. That's all about on this one. By the way, this is the critical points here, 3 and 2. Okay. And we have now example number 2. Find the interval or intervals where the function f of x equal to x cubed minus 6x squared plus 4 is increasing and where it is decreasing. So we have here the function. Okay, so the first step that we're going to do is we need to have, right, the function f of x is equal to x cubed minus 6x squared plus 4. The first step that we're going to do is we need to find the first derivative. Take note of the first step is finding the first derivative. Why? Because the first derivative, we need to get the angle, whether that one is obtuse or acute angle. So the first derivative is equal to, this one is 3x squared minus 12x. And after which we have to factor in order for us to get the critical points. What are the critical points? By equating this one into 0. So we have here 3x and x minus 4. So we have to equate this one, the function, in step number 2. This is 3x is equal to 0 and x minus 4 is equal to 0. So we have here x is equal to 0 and x is equal to 4. So we could now deduce now into our interval by using the horizontal line. In step number 3, we have here getting the interval. If this is our partly, this is our 0, this is a point here. This is 0. And this one is 1, 2, 3, 4. So the interval is this part, 0 and this one. So we can deduce now that our interval in this particular function is, we have here negative infinity, open, and close to 0. This is the first interval. And the second interval is 0, close to 0, and close to 4. And the third one is 4, close to 4 to positive infinity. Alright, so we have here, this is the third step. The third step, we have now the interval, the three intervals, I1, I2, and I3. The next step is we need to choose the value. Okay, choose the value. So in this particular, this is step number 4. So interval, this one is, interval 1 is negative infinity to 0. So we could choose let x is equal to, it could be negative 1. So if that's negative 1, so we have to substitute it in the first derivative function to get the slope. We have here 3 times negative 1 squared minus 12 times negative 1. So we have here 3 times negative 1 squared minus 12 minus 12 times negative 1. The resulting one is, when we substitute negative 1 here, is 15. So we could conclude that the function is greater than 0, so therefore this is increasing. In this particular interval, the function is increasing. And we have here interval number 2. In interval number 2, that is close to 0 and 4. So we have here let x is equal to, let us have 1. So we can execute by substituting the value for x is equal to 1. So the first derivative, 1 here, substitute 1. That's 3 times 1 squared minus 12 times 1. So the first derivative, when we substitute the value for x is equal to 1, the resulting one is negative 9. So we could say that the function, or we could conclude that the function f of f prime x is lesser than 0. So therefore, this is decreasing in this particular interval. And the last interval that we're going to have is interval number 3. In interval number 3, so we have here close to 4 to positive infinity. So let us have, let x is equal to, we could use 5 because that is within the interval 4 to infinity, that is 5. Okay, so when we substitute the value for 5 here, so 3 times 5 squared minus 12 times 5, the result of this one, or the resulting one, is equal to 15. So if that is equal to 15, we could deduce that the function is greater than 0, so therefore this is increasing in this particular interval. So now in the interval I1, that is increasing, and interval 2 that is decreasing, and interval 3 that is increasing. We just, without looking at the graph, we could say that increasing, decreasing, and increasing in that particular interval. Okay, so if we're going to look at the graph here for the function x cubed minus 6x squared plus 4 with the roots and critical points, we could say that in this value, this particular value, from this interval, negative infinity to 0, the graph is, or this in particular interval, the graph is increasing. But going to positive 4, the graph, at the point of critical point 4, the graph is decreasing. And in the third interval, the graph is increasing with that particular 4 to infinity, positive infinity. So by just looking at this one, by that just looking at the graph, so we could say, or we could conclude that the function in that particular interval is increasing or decreasing. That's all about example number 2. Okay, try this one at home. So find the interval of, or intervals where the function is increasing and where it is decreasing. So the first equation or the function is f of x is equal to x cubed minus 3x plus 3. And letter B is f of x is equal to 3x squared minus 6x minus 9. So if you have questions or clarifications with regard to this topic, please send message to our group chat for clarifications. Thank you so much for listening, and please try this one and so write this one in a long bond paper. Thank you and God bless everyone.